goal of this component is to provide a way to enhance WebAssembly's access control capabilities without requiring changes to applications. The WebAssembly System Interface is used to provide access to the outside world from an application, and it provides a form of capability-based access control where applications can only access things outside of the sandbox using handles which have restrictions attached to them. For example, an application might get a handle to a directory which will allow them to open files within that directory. The problem is that the restrictions that you can attach to the handle are limited to those in the WASI standard because they're implemented by the runtime. So this means that you can't do interesting application-specific things like have a handle that will only allow full lines to be written to a log file so that a component can't corrupt the audit logs of an application. So what we want to do then is to provide a way to automatically intercept traffic between these component interfaces so that we can insert new functionality. So the WebAssembly component model provides really well-defined internal interfaces within applications that allow you to insert a shim component that will implement this functionality. You will link components together using the WAC composition language, and then instead what we'll do is we'll modify this WAC file using our new tool, WACI. This will insert the shim into the application and can provide any kind of functionality that you can implement in Wasm, whether it's access control or data transformations like you'll see in this demo, or data capture like you'll see in the Demonstrator 2 MVP. In the Demonstrator 2 MVP, we use this component to capture data traveling between two Wasm interfaces. But in general, in the architecture of Elastic, this falls mainly into these two main connections here, access control and WASI. So for our demonstration, we have an application that's made up of three components. A trusted entry point component, which is going to read some text from the terminal. An untrusted internal component, and this is going to read some text from a file and then print it out. We then have an I/O component, the exporter, which will route the output of other components to the terminal. The problem is that you can't distinguish between the output from the trusted and the untrusted components. The I/O component, it just sees it got a call from one of these two components. So the new tool WACI inserts a shim into the application, which will apply a purple color to any printed text. And this will then allow us to differentiate trusted and untrusted output, because anything from this untrusted component is going to go through this shim, which will mark the text so that it's visually distinguishable in the terminal. So let's see how this works. We have this WAC script, which defines the application in terms of these three components. And we can use the WAC tool then to compose these to produce one single component, which we're going to put in the file output.wasm, and which we can then run using the wasm time runtime. And when we do this, we're going to see that the untrusted component is going to produce its output, and the trusted component will produce its output. And there's no way to visually distinguish between them. We don't know whether the untrusted component actually is just pretending to be the trusted one. So instead, what we want to do is to add a shim. And so we have this configuration file that indicates which component is to have the shim attached to it. We run WACI, and then this will produce a new WAC file that contains the shim. And so now the untrusted component can only communicate with the exporter through this shim. So we use WAC to take this modified WAC file and produce the application component. And once we've done this, we then run it with the wasm time runtime as before. Only this time, what we're going to see is that the output from the untrusted component is going to be distinguished from the trusted output by marking it with a different color. So now that you've seen this, what's planned for the next period? Well, first, we would like to provide a way to automatically generate these shim scaffolds. At the moment, we ask shim developers to just write the right interfaces for their components and work it out themselves, which is fine for a prototype, but ideally we would like to ease the effort of this so that you can just say, this is the interface I want to add a shim, and it will generate the boilerplate for a component for you that will shim that interface. But also we would like to expand the applicability of this. At the moment, we're just shimming simple interfaces, but we can't yet deal with Wasm resources. So resources are handles to objects that are managed by the runtime or by some other component. And this is what is used in WASI quite a lot to provide these handles and to provide these capabilities. The challenge, though, is that Wasm doesn't provide any polymorphism. And if you want to try to shim a resource, then you need to make some global changes to the application. And we then want to work out how can we make these changes efficiently or to avoid them altogether.